Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association. Welcome to Training Video Series 2, where we will explore the companion specifications. I hope you find these videos helpful. In this video, we will look at the STS203-1 companion specification. Please refer to the relevant document for detailed descriptions. And that document is STS203-1, Method for Default Payment Meter Values for Conformance Testing. When sending meter samples for conformance testing, 7 samples are requested as per the STS test documents. Each sample is set up according to a particular set of parameters, and here they are. For entity type D, the meter must be labeled DUUTO2. It must be in a DRTK mode with all Fs. It must have full credit, and the document to refer to is 531-4. The TID value in the meter in the entire TID stack must be 5A45A1. In fact, for all of the meters, that TID value is relevant. Then you have entity type E, and you've got 3 meters labeled UTO1, 02, and 03, all with DRTKs of Fs. And then the last 3 are for entity type F. They are labeled UTO1, 02, 03, but with an F in front of them. And they're all under DRTK, all ones. In all the meters except the entity type D, the meter must be loaded with 0 credit. This is quite cumbersome, and transport costs are high since you need to ship 7 samples. So in order to maybe allow you to ship less samples, then STS203-1 gives a method for default payment meter values for conformance testing, where only 1 sample is required for testing. The sample has a method of resetting these initial parameters by way of a shortcode or writing to a particular register in the meter. And the way it works is that the meter is in a factory state, or the meter is in a manufacturer default state, or the meter is in operational state. Now, if the meter gets sent back to the factory, it goes into a factory state, and then it can get coded into a default SGC and shipped out. The method we are proposing now is that the meter can go into a CTS test state for 24 hours. And that's what STS203-1 specifies. In other words, you can put it into a special state where the meter is allowed to accept either a token or a shortcode that sets the meter into any of the 7 initial states required for testing. After that it's done, it's got to have a powered up timer inside the meter that after 24 hours, the meter will revert from a CTS test state into a dead state, which effectively means the meter needs to go back to the factory to be reset again to be usable. Okay, so there is that option to get this meter done that way. Or alternatively, the meter can be shipped out for testing and then shipped back to the factory, and that functionality disabled. But the meter is never allowed to leave the factory with that default CTS state enabled. So how does it work? We assign a short code via the keypad or communications channel or a token to set the meter to any of the initial states. Or we write to a particular register. For example, if you see STS201-1, it allows you to write up to 99 different states. The meter DRN must be one of the following: for a 2-digit manufacturer code meter, all zeros, and for a 4-digit manufacturer code meter, 01, then all zeros and an 8. Note that shortcodes are not specified in this document. This is left to the manufacturer to allocate these. Rules for this feature: only meters with the DRN specified may be able to be set using this method. The meter must have a powered up timer that resets the meter to a dead state when the timer expires. That's 24 hours, and there should be no method to be able to reset the timer. The CTS test mode is exited when the test timer expired, or a shortcode is entered to disable the test mode. When exiting the test mode, the meter shall enter a dead state. It will no longer be able to dispense a utility or accept any tokens or shortcodes. And please remember, no meter may be shipped out to customers with this feature enabled. The benefits of using the CTS test mode: you only need to ship one sample, but it's probably always better to ship a second sample as a backup, just in case the first one has a fault with it or gets damaged in transit. This significantly reduces transport costs. The meter can be reset multiple times in case an issue is encountered during testing. No special preparation of samples is required for certification testing. And automated testing may be done for meters that are being tested for virtual token carrier port compliance. For example, with a DLMS meter or VTC07 meter, it would be very difficult to have to stop halfway, reset the meter to another state, put it back in again, as opposed to if you have a test mode where you can just write to a register, you can actually run through the entire sequence just by getting the test harness to write the correct value into the CTS register. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope to see you for the rest of the video series. Goodbye and see you again soon.